Hey everyone, welcome to Tutort Academy. So my name is Chirag Vaishnav, and in this video we will be discussing a very special problem of DP, continuing with the 2D DP that we have started, that we have been ongoing through the DP series of DP questions that we are working, right? So the question today we are going to solve is minimum path sum, right? So it's very standard 2D DP problem. It's kind of a beginner 2D DP problem if you want to jump deep dive into it. So we will be discussing it today, so I'm really excited for this, right, to explain this, that how it all works, because I have learned a lot from this as well, right? So let me first discuss that what will be the flow of this video. So then we will discuss that about logic and all the things. So first I will introduce you to the question, that what question says basically, then we'll run some test cases basic. After that I will help you explain the logic, that what will be the logic building on which we will be writing a code, and after that we will be discussing our code, and I'm definitely sure that you will understand a lot of things in this. So without further ado, let's first start with the problem statement. Okay, so here we are. So the problem simply states that you are given a m cross n grid filled with non-negative numbers, right? So it's a very important thing, non-negative numbers. It simply means that it's non-negative. It can be 0, 1, 2, 3, 4 and so forth, right? So you have to find a path from top left to the bottom right, which minimizes the sum of all number along its path, right? And you can move either down or right at any point in time, right? So what it simply means is that suppose I'm standing here at 1 on the left top. So at each step I am having only two options: either I can go right, either I can go down, either I can go right, either I can go down, right? So suppose I went 3. So suppose I went to 3, then I went to 1, then I went to 1, then I went to 1. So what this will simply state that this is my minimum answer, you can say, right? This is the minimum number of steps that I can take to get there, right? So this is how it works, right? So we will I hope you got basic idea, but if you haven't till now, don't worry, we will be discussing it in detail, right? So these are the test cases basically. So let me just head over to the PowerPoint presentation so that I can help you explain it more, right? So let me just copy this image. So I have opened it. Cool. Okay, so here we are. So let me start it. Okay, so this is the basic array that we have given. What you have to do, you have to find minimum path sum, right? What you have to do, you have to find the minimum path sum. And for what are the things that we have been discussing in the question lately? This is my starting point and this is my ending point. Let me write it in a better way. This is my starting point and this is my ending point. And while standing at each position, what are the things that I'm being available with? So suppose I'm here at this position. So either I can go right or either I can go down. So these are the only two things that I am being available with. Either I can go one step right, either I can go one step down. And during the whole period of walking through, right, what you have to do, you have to find the minimum path that will be available or that you will avail at the end of your traversal when you will reach that end, right? So you will start from left top and you have to end to right bottom. Right, so these are the basic things that you have to deal with. Cool. So what will be the basic approach behind it, right? Suppose I started with here. So what are the two things that I can go? Either I can go here, either I can go here, right? Suppose I went to here. Now what are the two things that I can go? Either I can go here or either I can go here. Suppose I went here. So what are the two things that I can go to? Can I go like one more right? No, I cannot, right? So either I can go here, right? So and no more else place to go, right? Now let's come to here. So if I'm here, either I can go here or either I can go here, right? Suppose if I come to here, either I can go here or either I can go here, right? Similarly, when I will come to here, I cannot go one step right. What I can do, I can go down here, right? Now coming to here, I cannot go bottom, so I have to go here only. And at the final R star mark, I will be having this option, right? So one thing that you can observe, what I have done, I have tried to like for the first path I have tried single arrow, for the second path I have tried double lined arrow, for the third I have tried triple lined arrow and so forth, right? So what is the thing that I am basically trying to explain you, that at each position you are having two choice, right? Either you can go right or either you can go down. So what we can do, we can we calculate for each step and find the minimum out of it. What you have to do, you have to find the minimum path sum. Basically the DP problem that we are facing, each DP problem, it's somehow some utilization, some optimization of the approach, right? It's basically that only. Suppose I created a replica array and named it DP, right? So this is my DP array. So this is my DP array, right? So if I started with this, won't the sum will be 1 only, right? Now whenever we are using a DP array, the one thing that we have learned till now, that what we do, we basically initialize some things, and building on that only we form a whole table, right? So what you have to do, you have to keep in mind that okay, I have to initialize some things. Now in order to initialize, what you will be doing is, suppose if I am having 1 at the starting, right? So what will be the path sum for here to reach 3? Only I can go from left, okay? Because there is no way to go to come from top, because if I want to reach this 3, if I seeing from the perspective of 3, from where the values can come, either from here or either from here. So it is not a option, so only from here the value will come, right? So can we simply write that for the first row it will be 1 plus 3 will be 4, and 4 plus 1 will be 5. Will this be the sum? Because I cannot come from upside, right? So on the only direction that I can come with, I can go from here, I will reach here, and then I will go from here and I will reach here. So it will be 1 plus 3, 4 plus 1, 5. And the same case will go here as well. 1 plus 1, 2, and 2 plus 4, 6, right? So 1 plus 1, 2, and 2 plus 4, 6. So I hope you will get this point, right? So this will how we will initialize our first row and first column, right? Now jumping deep dive into the inside array, right? So what's happening inside only, right? So if I'm at this position, what will be my choices? If I'm at this position, what will be my choices? Either the one can come from top, okay? So we have discussed that from a position we can go either right or down, right? But if I'm at the receiving position, what will be the ways through which I can get the sum? Either someone can come from up, or someone can come from right. So this will be my only position. So either I can include 4 or I can include 2. These are the things, right? So either I can include 4 or either I can include 3. Now in order to think greedy, because there are two options, either I can count 4 or either I can count 2, right? So there are two options, that should we take 4 or should we take 2. Now thinking greedily, what is the thing that you are wanting or wishing to? You want to find the minimum path sum. So isn't that obvious that you will take the smallest out of them, right? So it will be suppose grid is the name of this table and DP is the name of this table, obviously. So isn't it will be greedy of I comma j, because if we are moving to that point and you have to move through all the points, this is the thing, right, while calculating. So this will be calculated, obviously. Plus now what will be the path that we will be traversing through? Either I can go move up or right. So these are the two things from which I can take the sum. So won't we take the minimum out of that? So out of 4 and 2, what is the minimum? 2. And what is the value of this? 5. So 5 plus 2, it's 7, right? So 5 plus 2. So now till now the path is this. Till now the path that we have chosen is this. right, is this. Right, now when I will come to here 1, so there are two options, either I can go with 5 or 7, right? So it will be which is smaller, 5 obviously, so 5 plus 1, 6 it will be, right? Now coming to here, so there are two options, 7 or 6, obviously 6 is smaller, so 6 plus 2, 8, right? Now out of 6 and 8, which is smaller, 6, and what is the current value, 1, 7, so 7 is the minimum path sum that we are having, that we are available, right? So what we have to do, basically first you have to initialize the first column with the sum consecutive sums, because these are the only possible ways, because these are the boundary cases. And after that, while building into the array, what you have to do, you have to find the minimum of up and right, and obviously you have to count that element into the sum, because you are traversing through that index. So this is how we will be dealing with this. So I hope you got the explanation right. Now let's head over to the code part. So the code part is similar as well. What we will be doing is, we will be taking row size, column size, and we will be making a DP, and we will be initializing the first row with the sum. We will be initializing the first column with the sum, and then while building the DP, what we will be doing is, we will be adding the particular sum of the index and minimum of right and top. So and the end, we will be returning the right bottom part, right bottom right of the DP array, and that will be our answer. So I hope you got the solution right. If you like this video, do give a thumbs up and make sure to subscribe to this channel, and if you are having any doubt, you can ask in the comment section. I will definitely answer it. So thanks for watching, and see you in the next video.